Let us look at magnitude of a vector. Magnitude is also known as modulus, or the length of the vector. Given vector AB, the modulus of the vector is symbolized AB with two lines. AB with two lines. So that is the modulus or the magnitude of a vector. If given vector AB is equal to xy, where x is the displacement along the x axis parallel to the x-axis and y is the displacement parallel to y-axis, this one is also parallel to x-axis, as illustrated below. We have AB, vector AB, we have x as displacement parallel to the x-axis and y as displacement parallel to the y-axis, so that A is displaced from x1 to x2 along the x-axis and A is displaced from y1 to y2 along the y-axis. Then we write the modulus of AB is equal to the square root of x squared plus y squared. From Pythagoras' theorem, a right-angled triangle is formed with AB as the hypotenuse. But from the figure, x is equal to x2 minus x1 and y is equal to y2 minus y1. Therefore, we say that AB, the modulus AB, is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, where, of course, x2 minus x1 is equal to x and y2 minus y1 is equal to y. In the second case, we have vector BA. The direction is reverse to the direction AB. x1 minus x2 is still x, y1 minus y2 is still y. So BA, modulus BA is y units downwards and x units towards the left. So because of the change of direction, y will be negative and x will also be negative. So BA will be the square root of negative x squared plus negative y squared. And this still gives us the square root of x squared plus y squared. So whether the direction is positive or negative, the modulus is the same in either case. Example: calculate the magnitude of the vector represented in the figure below. So we have vector mn. Point M has coordinates 2, 1, and point N has coordinates 6, 4. The displacement of M parallel to x-axis is from point 2 to point 6, which gives us 4 units, while displacement along y-axis parallel to y-axis is from point 1 to point 3, which gives us 3 units. Using this, we get that the modulus of mn is equal to the square root of 4 squared plus 3 squared, which is equal to the square root of 16 plus 9, and that gives us the square root of 25, and therefore the modulus mn, modulus of vector mn, is equal to 5 units. The same can be determined from the coordinates, so that mn modulus can also be given as, using the coordinates, we subtract the corresponding x ordinates of m and n, so we have 6 minus 2 squared plus 4 minus 1 squared. That gives us 4 squared plus 3 squared, and that gives us the square root of 25, and this is equal to 5 units. Based on the above example, the magnitude stroke modulus of a vector can be obtained from the coordinates of the endpoints of the vector, that is, in general, given point Q, x1, y1, and r, x2, y2, the magnitude stroke modulus of QR is given by QR modulus is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Or square root of x1 minus x2 squared plus y1 minus y2 squared. Both expressions will give us the same answer. Calculate the modulus or magnitudes of the following vectors. Vector AB, given A, -1, -3, and B, 4, -7. Then we have vector CD, given C is 3, -2, and D, 0, -1. Applying the above formula, we find that AB, the modulus of AB, is given by the square root of 4 minus 1 squared plus -7 minus 3 squared, which is equal to the square root of 5 squared plus -4 squared. This gives us 25 plus 16. And 25 plus 16 is equal to the square root of 41, so that the modulus of AB is equal to the square root of 41, which gives us 6.403 units. So that is for part A. For part B, the modulus of vector CD is equal to the square root of 3 minus 0 squared plus -2 minus -1 squared. This is equal to the square root of 3 squared plus the square root of -1 squared. And this gives us the square root of 10. So CD modulus is the square root of 10, which is equal to 3.162 units.